So like yesterday we did the first three, and then you'll see here I did the last one in like kind of some magenta kind of colored, right? And what I kind of want you guys to see is that for any of these graphs, right? So if I do the original, I'll just highlight them. If I do the original in black, right? You're always going to know the black one. You have to know that one, right? So that's the graph of y equals x squared with the parent function, right? And then from there, the only thing that's changing is I'm taking the original, right? And I'm adding something to the end of it, right? So then this whole graph just is the first one, the black one. I'm going to take every point on the black one and I'm going to move it up 2, right? The y ones, right? So all the y values are what's changing, right? So if I look at the blue graph that's here, every one of those points is 2 units higher than the black one, right? You just see it, right? And the more and more of these that I do, right? The magenta one, I see that the Q value is 4. So I've taken the black graph and I've moved the black graph up 4 units. That's the magenta one now, right? So you can see that that term on the end is just taking the original. It's how we change the original, and then to the last one. That's what we call like transformations, right? And the last one's red. The red, the Q value was -3 this time, right? So I'm going to take the black graph and I'm going to move it down 3 units, right? Every point. So generally speaking, right? This Q, this notion of Q, right, is us physically taking the original. It takes the original, that's important, it's always relative to the original, and we physically move it up or down, right, depending on the sign of Q. So is it positive or negative? That makes sense? So then there's really not much else to go on. There's three other transformations, which you can work through, right? So if we like, I can see here, I know what this graph's going to look like now, right? I don't need, if I know what the original looks like, if I've memorized it, right? I don't need a table of values. I know that the black graph, this is just the black graph, x squared. And if I get rid of the scribbles, I'm going to physically move the black graph up 5. That's all I'm doing. Right? So I don't actually need the table of values to do these, right? To see what they look like. It's just keeping track of what's actually happening, right? And then this one I'm just going to move down 1, right? So it's going to be in between the black graph and the red one from the original question. Right? 1 unit down. Okay, is everybody okay with that? Now, let's go, again, same thing. This is just with lines, right? So we're just taking the original, which is going to be black. I'll do this one just quickly. Y equals 2x is going to intersect there. And then I'm going to go up 2, right 1. Up 2, right 1. Up 2, right 1. Then I go down 2, left 1. Right? That's the graph. Y equals 2x, right? And then all that changes from that graph is that I'm going to take it and I'm going to move it up 3, down 1, up 4, right? So I'll do one of them just so we've got it. I'll take one of them and we'll do the +4 one, right? So I'm going to take every point on this graph and I'm going to move it up 4 units. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And so on, right? Right? That's the graph y equals 2x plus 4. Right? So that's what we call, like, in your definition up here, we could call Q as being the vertical translation. Right? So it's me moving the graph up and down vertically. Okay? You're okay with that? And then I just wanted to reiterate it with this one down here. I just wanted to reiterate what it was that was going on, right? It's the same like idea. It's just a line this time, but I'm moving it up and down. That's all, right? This isn't going to get any harder than that, really, except for maybe the horizontal piece, right? But this one here, now I want to look at something different, right? The idea is the same. I'm just looking for a pattern. This time I'm going to introduce a coefficient, right? So I'm going to like, something's going to happen to the values of the graph, and we're going to see a pattern, right? So again, all I care about is the original, right? Y equals x squared, which I know the points for now, right? Negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. So if I go plot that down here, it's still just the same graph, right? All right. There's the original graph. You have to know this one. Okay. And then from there, the only thing that changes now is I've added this coefficient in. So our question is, what happens when I do that? Right? So in order to see it, I want to compare with the same x values, right? And then you want to see what happens. Okay, well, if I plug in negative 2 here, right? That's going to equal 2 times 4, which is going to equal to 8. Right? So then my output here is negative 2, 8. Same thing here. So if I plug in negative 1, I'm going to get negative 1 times negative 1 is going to be 1 times 2 is going to be 2. Right? 0 squared is 0 times 2 is 0. Right? And then you get this symmetry about what's going on here, right? So now I'll plot this one in red, okay? So what's happened is my question, right? So let's plot those points, and then we can visually see what happened, right? So we still get 0, 0, right? Negative 1, 2. Let's do that one. Negative 1, 2. Negative 2, 8. It should be all the way up here, right? And then I get symmetry about the y-axis, right? So on the other side, I'm going to get positive 2, 8, and 1, 2. So my question to you is, what's the difference between the red graph and the black one? Like visually looking at it, it looks a little bit skinnier, right? So it looks like I've taken the top of the graph and I've pulled on it and made it skinnier, right? So we call that like a vertical stretch, right? So basically, essentially, what's A is, it's a vertical stretch / compression. Okay? It's a stretch when the value is bigger than 1, which I'll summarize at the bottom here. But let's look at what happens if I were to plug in, we'll do this one here. Okay? I know you can't see that. Okay, we'll put this one in blue. So if I input my values, same values, I want a direct comparison, negative 2, negative 1, 0, 1, 2, right? If I input those values, what do you think is going to happen to the graph? Can we look can we look at, like, here's I'll show you a little trick here. If we look at the y values for this graph, okay, and then I flip over here and I look at the y values over here, what happened? They doubled, right? They doubled because it's a vertical, it's affecting the graph vertically, right? But you can see how, like, this is times 2. Well, where's the times 2 from? Out front, right? So it's vertically stretching the graph by a factor of 2, right? Now, what do you think is going to happen with that, following that pattern? If I take this guy here now, oops, I wanted the highlighter. If I take this and do it in orange, what's going to happen to the values over here? Follow the same pattern, right? These ones I multiplied by 2, but if I'm going to go from, if the coefficient is now 1/2 relative to this, then what's going to happen? I'm going to multiply by 1/2, right, in order to fill that table of values. So whatever the original was, in this case it was 4. Half of 4 is going to be, whatever color is doing. Half of 4 is going to be 2. Half of 1 is going to be 0.5. Half of 0 is still 0. And then you get 0.5. And you get 2. Right? So let's plot this one, and then we'll talk about the differences between those 3 graphs, right? So let's go plot them. So -2 and 2, that's right there. Right? -1 and 0.5 is right there. 0, 0 still, and then I get symmetry about the y-axis. So what's the difference between those graphs? I'll give you 3 examples there, right? One is the original, the black one. You have to know that always. The red one was me grabbing the top of it and pulling on it by a factor of 2, right? The blue one is me on top of the graph pushing down. So I've compressed it by a factor of 2, or 1/2, right? Does that make sense? So I made the graph shorter and wider, right? Relative to the red one, when I pull on it, the red one got skinnier and taller because I vertically stretched it, right? So your rules down here, we could just fill this out, okay? Basically what I wrote up here, A is the vertical stretch / compression, right? And then obviously whatever the factor is the factor, right? So when A is greater than 1, so you can see how, like, the pattern changed here, right? What happened to the values when A was bigger than 1? They got bigger, right? So then if the y values get bigger, then we have to know this is a vertical stretch. Right? Right here, though, this is saying that the A value is between 0 and 1. Right? That's what that's physically saying, right? So, for example, (1/2) is in between 0 and 1, right? If it's in between 0 and 1, then it's the y values get smaller, right? And so this is what's known as a vertical compression. Okay? We're almost done. Okay? It doesn't seem like it because I think you guys got like 4 pages to do, but honestly, like there's one more, and then the other one's really easy. Right? So if you were to fill a table of values, like you were just plugging in things and filling this out like in the tedious manner that it is, you would, and then plotted the graphs, you would see all these patterns, right? Like this is just me coming up with the patterns based on you plotting them, right? So you could go plot these now. I know what the original looks like. You always have the original to go off of, right? And then what you're doing is you're going to physically take, okay, well, we'll just do 2 quickly. Okay. I see that this point right here is 4 units away from the x-axis, so I'm just going to multiply it by 2. So it is 4 away, so then it's going to go to 8, right? This one's 1 away, so it's going to go to 2. This one's 1 away, it's going to go to 2, and this one was 4 away, so it's going to go to 8. And there's your transform graph. Okay. Same would be true if I saw the half. Yeah.
Does the square root tell you that it's going to be a parabola, or like?
Yeah.
So if it wasn't there, it would be a line.
It'd be a line. Okay. Yeah, and then the a value is just the slope. If it's a line, that's just a slope. So either like it's just getting steeper or not as steep, right? So, and I know that's a good question. So, I know it's a parabola because of this, the squared. I also know, if you remember doing this, I'll try to find one here. If you guys remember doing this, the first difference is, remember doing this? So 1 minus 4 is negative 3. 0 minus 1 is negative 1. 1 minus 0 is 1. 4 minus 1 is 3. They're not the same, right? If they had have been the same, then it would have been a line, right? Now, if I do this again, this is what's known as the second differences. Negative 1 minus negative 3, so 2 negatives here. So it's basically negative 1 plus 3 is going to be 2. 1 minus negative 2 is going to be 2, and 3 minus 1 is 2. Sorry, that's messy. Okay. So I see the second differences are the same, right? I therefore know it's a parabola because the second differences are the same, right? If I went up here and did the lines, we didn't have lines on this one. So if I did the table of values for a line, the first differences would have come out to be the same, right? So you know that's a clue. If you see the squared there, that means it's a parabola, right? And like that's typically all we're going to really do, right? Is we're just graphing parabolas, okay? This one's might be the easiest of all of them. Well, maybe not actually. They're all pretty. Like the first 3 are relatively easy. The last one's probably the hardest, okay? Do we know what the negative stands for? Yeah. So basically, like if I were to plug in the values, so I'll do the table of values just for consistency's sake, right? Negative 2, negative 1, 0, 1, 2. That's 4, 1, 0, 1, 4, right? So what happens if I throw the negative out front? Well, all the y values become negative, right? So if I just compare negative 2, negative 1, 0, 1, 2, right? Negative 2 squared is going to be 4, multiplied by the negative is going to be negative 4. Then negative 1, 0, negative 1, negative 4, right? So basically if I plot these two graphs, right? If I plot these two graphs, that's y equals x squared. Then y equals negative x squared is just a reflection in the x-axis. So I'm basically going to take the graph and all the values become negative. So this one's going to go to here, 0 is still 0. One too many. Okay. So that's y equals negative x squared. Okay, so it's basically, you could put in the rule that this is a reflection or also known as like a vertical reflection, you could say, right? Okay, not much to that one. That's just me flipping the graphs. Just one more transformation that you guys are done, right? One more thing I can do to this. Okay. That's basically the last page, right? Is if I give you a whole bunch of these things now, you better be able to do all four of them. That's the end goal. That's the product that we want to be able to get to, right? Okay. And we do that with the introduction of brackets. Okay. Right. So this here, if I were to do the tables on it, this is the hardest of the four. Okay. It's only hard because once you know the rule, it's easy, but it's the hardest of the four. Okay. So we'll plot in the points, right? So I go -2, -1, 0, 1, 2. I'm going to plug in the values of x. -2 plus 2 is 0. 0 squared is 0. Right? Did we see that? -1 plus 2 is going to be 1. 1 squared is 1. 0 plus 2 is going to be 2. 2 squared is 4. 1 plus 2 is 3. 3 squared should be 9. Okay? And then 2 plus 2 is 4. 4 squared is 16. Okay, you might notice this looks a little bit awkward, right? So let's plot those points. Okay, we'll plot the original. You'll find that this is the reason why this is the hardest of the three. Right? It's a little bit awkward, but hopefully this I've never done it this way. The table of values is helpful because it shows things. Okay, but let's go plot that. So the black one's the base graph, right? And then I'll go plot these points. -2, 0, right? And then I'll plot, okay, -1, 1. Then I'll plot 0, 4. And then I'll plot 1 and 9 would be up here. What's the problem with this? Do we see any relationship between the points? Like, what if I got rid of this here? Oh, I'm off by 1. I'm off by 1. Do we see any relationship between those 3 points and the black graph? Yeah.
It's been moved to the left.
It's been moved to the left, right? But I only see half the graph, right? So if I'm moving things left and right, it affects things horizontally. What's the horizontal axis? X, right? So if I'm changing things in X, then my table of values has to change in response. Otherwise, I'm only going to get half the graph, right? So if I were to plot, what would happen if I plotted -3 what's the output for negative 3? Well, negative 3 plus 2 is negative 1. Negative 1 squared is 1. So then I can plot negative 3 and 1. I start getting the other half of the graph, right? Negative 4. What happens if I plug in negative 4? Negative 4 plus 2 is negative 2. Negative 2 squared is positive 4. And just like that, I get the graph. There's one other. This is what makes this tricky, right? What's the pattern I'm seeing here? Relative to the equation, do you see anything awkward that happened from the equation relative to what actually happened with the graph? There's something counterintuitive. What's the sign? Normally I would associate a plus sign with going to the right, but that's not the case, right? It's opposite. So if I see a plus sign, I have to go left. I have to move the graph left. If I see a minus sign, the graph's going to go to the right, right? So if I were to do this one here, I'll do this graph in blue. You could check the tables of values if you want. Okay, I see a minus sign here in between inside the brackets. So anything inside the brackets is horizontal, and it affects it in the opposite way that you might think. So here, I'm going to take the black graph and I'm going to move the black graph to the right one. Every point gets moved to the right one. Right? Right? You can confirm that with the table of values. So I suppose my goal is for you, and your goal will be to, if I give you a mess of all 4 transformations, you take the base one and you apply all 4 transformations to it. Your reflections, your vertical movements, your stretches or compressions, and then your horizontal movement. Right? So just to summarize this, H obviously stands for like horizontal, right? H is horizontal. And it behaves okay. So in which case we'd say like if H were positive 3, the graph we would say like mathematically, like I'll give you the be horizontally translated three units left. Is that okay? Okay, so if I give you, I'll let you finish writing that. But if I give you like a mess, I'll give you an example in a sec. And the other thing we've done with this is we've like built a specific form of the parabola too, right? So it's a new one that most of you probably haven't seen unless you've done the 2D math, right? So that's like y, there's 3 forms. There's y equals x squared plus x plus b or whatever. Or plus c, I suppose. Right? And you had coefficients. And then you had y equals x minus a number multiplied by x minus a number, right? We'll go over all these again. This is what was factored, right? and then this was standard, and what we've built today is what's known as vertex, right? And it follows the form y equals ax minus h squared plus k, or q. You could put q. I know we use q. I think k is the grade 10, right? There's your h, vertical stretch, horizontal. There's your vertical movements, right? So in the instance in which I give you something like this, okay, and maybe we'll plug away with the Desmos activity today because I think that's kind of cool, is you're going to be given a parabola, and it could have all four of these things in here. Negative 2x plus 2 squared minus 1, right? You've basically taken the original graph, y equals x squared, and you now have introduced vertical stretches, reflections, horizontal movements, and vertical movements. You got 4 different translations to keep track of, or transformations, right? We'll call it. So you'll get one graph at the very end, right? With all those transformations that we talked about in this booklet. Does that make sense? So what we'll do now, okay, that should give you enough context to